The Jurassic world was a realm defined by scale. It was an empire of giants, ruled by vertebrates that strained the very limits of biological possibility. Forests of towering conifers and vast plains of ferns stretched to the horizon, but they were not empty. They were the domain of the sauropods, colossal, long-necked titans that remained the largest land animals ever to have walked the earth. But this grand spectacle presents one of the greatest paradoxes in paleontology. How did an animal, the size of a building, weighing tens of tons, power itself on a diet of prehistoric foliage? Now, let's open the fossil record and resurrect the story of this Jurassic titan. When we analyze the anatomy of a sauropod like Diplodocus or Apatosaurus, the mystery only deepens. We are looking at a biological engine that required a constant, massive intake of fuel. A single adult might have needed to consume hundreds of kilograms of plant matter every single day. Yet, when we examine the business end of this animal, the skull, we find something confounding. The head is remarkably small relative to its colossal body, and its mouth is equipped with simple, peg-like teeth. These teeth show wear patterns, preserved in the fossil record, that tell us their function. They were not for grinding, not for chewing, not for breaking down tough material. They were tools for raking and stripping. The sauropod would clamp its jaws on a branch and pull, shearing off leaves, stems, and even woody twigs, swallowing the entire mass whole. This is the heart of the sauropod feeding paradox. The energy available in their environment was locked away in plants rich in cellulose and lignin materials, notoriously difficult to digest. Cycads, ferns, and conifers are abrasive and nutrient-poor compared to the grasses and fruits that fuel modern herbivores. The sauropod's primary digestive tool, the mouth, was doing almost no processing. It was simply a harvesting mechanism, a conveyor belt shoveling raw material into a vast internal system. To survive, let alone thrive and dominate ecosystems across the globe, these giants must have possessed a digestive adaptation that compensated for their seemingly inefficient mouths. They were specialists in bulk feeding, but that bulk material was useless unless it could be broken down. Chewing, the process that mammals perfected, starts digestion by mechanically shredding food, increasing its surface area for chemical attack by enzymes. Without this crucial first step, how did the sauropods unlock the energy trapped within the tough, fibrous walls of Jurassic flora? The problem is one of physics and biology. A larger animal has a slower metabolism relative to its size, but its sheer, absolute mass requires an incredible amount of total energy. This animal was a furnace that had to be perpetually stoked, yet it was feeding itself literal timber. We see evidence of this high-volume feeding in their ecology. Sauropods were keystone species, their constant browsing reshaping the entire landscape, creating clearings and altering the course of plant evolution. This profound biological puzzle, a high-demand engine paired with low-grade fuel and minimal oral processing, forced paleontologists to look deeper, past the teeth, and into the very core of the animal's body. The answer, it turns out, was not in their mouths, but hidden deep within their digestive tracts. A solution so effective, it allowed them to become the most successful group of large herbivores the planet has ever known. The solution to the sauropod paradox was not a theory developed in isolation. It was unearthed from the ground, found lying alongside the giants themselves. For over a century, paleontologists excavating sauropod skeletons were occasionally mystified by collections of smooth, highly polished stones clustered within the rib cage, in the precise area where the digestive tract would have resided in life. These were not random river rocks that had washed into the burial site. Their texture was wrong, gleaming with a high-gloss stomach polish that was inconsistent with sand or water erosion. Furthermore, their geology was often alien to the surrounding rock formation, implying they had been transported, sometimes over great distances, before being deposited with the dinosaur. These are gastroliths, or stomach stones. Their presence provides the crucial, tangible evidence for an extraordinary digestive system, the gastric mill. This adaptation, while sounding ancient, is very much alive today. When we analyze the digestive strategy of the sauropods' living descendants birds, we find the exact same principle at work. An ostrich, for example, swallows its food whole, along with pebbles and stones. These stones lodge in a specialized, incredibly powerful muscular pouch of the stomach called the gizzard. This gizzard contracts rhythmically, churning the stones against the food, pulverizing seeds, fiber, and even bone into a digestible pulp. By applying this modern analogy, we can resurrect the lost biology of the sauropod. The giant herbivore would intentionally swallow stones, likely selecting them for their hardness and shape. These stones would accumulate in their own powerful gizzard, forming a permanent internal rock tumbler. The mountains of stripped conifer needles and cycad fronds, swallowed whole, would pass from the esophagus into this churning mill. We must imagine the forces at play. This was not a gentle process. It was a powerful, visceral engine. The muscular walls of the gizzard, inferred from the sheer mass of stones they had to move, would contract and grind, smashing the gastroliths against each other and against the tough plant matter. This process, operating 24 hours a day, did what the teeth failed to do. It mechanically shattered the plant fibers, breaking down the tough cellulose and lignin, massively increasing the surface area for the chemical digestion that would follow in the intestines. The stones themselves, as confirmed by the fossil record, were slowly worn down in this process, ground into smooth, polished spheres before eventually being passed or replaced. This system is a masterpiece of biological engineering, and it solved multiple problems at once. Most importantly, it decoupled the function of harvesting from the function of processing. It allowed the sauropod head to evolve into a specialized, lightweight tool. A head designed for heavy grinding, like that of a modern cow, requires massive jaw muscles and heavy teeth, anchoring to a thick, reinforced skull. Such a head would be impossibly heavy to place at the end of a 5-meter-long neck. The biological cost would be too high. The physics simply wouldn't work. By outsourcing the chewing to a gizzard located deep within the torso, the head was freed to become small and light. This anatomical liberation is precisely what allowed for the evolution of the sauropod's most iconic feature, the hyper-elongated neck. The gastric mill, therefore, is not just a digestive quirk. It is the fundamental adaptation, the evolutionary key that unlocked the sauropod body plan. It allowed them to stand in one place and browse a vast feeding envelope, reaching high into the canopy to harvest food sources that no other contemporary herbivore could touch. They became the first high browsers, changing the very structure of Jurassic forests. The stomach stones were, in essence, the engine that powered the rise of the giants. The gastric mill was not merely an anatomical curiosity. It was the biological engine that fueled the sauropod's global dynasty. This adaptation provided a profound, game-changing advantage in the Jurassic ecosystems. In a world where the most abundant food sources, conifers, cycads, and ferns, were locked behind tough, fibrous defenses, the sauropods became the ultimate processors. They didn't need to specialize in soft, easy-to-digest plants. They could eat everything. This hyper-efficient digestive strategy is what underwrote their entire ecological niche. It allowed them to extract the maximum possible energy from low-quality, high-volume food, fueling the immense metabolic demands of gigantism. Their colossal size, in turn, granted them virtual immunity from all but the largest predators and allowed them to function as ecological engineers. their browsing patterns shaping the very structure of the forests they inhabited. When we analyze the fossil record, the evidence of this success is overwhelming. Sauropod remains are found on every continent, from the Morrison Formation of North America to the Tendaguru beds of Africa and the fields of Asia. This staggering geographic distribution, which persisted for well over 100 million years, is the ultimate testament to the power of their adaptation. The Sauropod dynasty would have been biologically impossible without the gastric mill. But this evolutionary strategy did not die with them. We can trace its legacy through the grand tapestry of life. We see polished gastroliths associated with other dinosaur groups, including some armored ankylosaurs and horned ceratopsians, suggesting this was a successful solution adopted by multiple herbivorous lineages. However, the clearest evolutionary echo resonates in the sauropods' distant relatives. The living archosaurs, modern crocodilians, for instance, actively swallow stones, while their diet is carnivorous. The gastroliths serve a parallel function, helping to pulverize the bones, shells, and tough hides of their prey. And, of course, this adaptation is the standard for their only living dinosaur descendants, birds. From a sparrow to an emu, the gizzard, or muscular stomach, is a critical component of their digestive tract. It is the direct evolutionary continuation of the same biological machinery that powered the giants of the Jurassic. This evolutionary path stands in stark contrast to the one taken by mammals. Our lineage invested in a different solution: complex, specialized teeth. We mastered mastication, using heavy skulls and powerful jaw muscles to grind food before swallowing. The sauropods, by contrast, perfected a system of a simple head and a complex stomach. The humble gastrolith, a polished stone swallowed in a lost world, is the key that unlocks this magnificent divergence in life's engineering. The story of the gastrolith is a powerful reminder that evolution is not a single, linear path, but a branching delta of ingenious solutions. These simple, polished stones, swallowed in a world lost to time, were the critical gear in the engine of the largest creatures to ever live. They show us that to understand the Titan, we must first appreciate the pebble.